Hi, everyone. Today we're going to be discussing Chapter 8 and 9, and we're going to start going over and reviewing some of the basic data types and working with those. That is a key piece to being able to write your queries, convert data, and also help you put your database administrator hats on when you're designing your databases. So let's go ahead and get started. So let's discuss some of the most common data types that you will be seeing and that are commonly used when designing, architecting, and also just working with data. Some of the most common are going to be characters, which are just strings of character data. These can be really useful to hold alphanumeric values, things like if you're working at a place with members, member IDs, which can be alphanumeric, keywords or phrases, um, also numeric. Those can be anything from an integer, which are just whole numbers, to decimals, to floating. So there's a lot of different types of numeric data that you can be working with, just depending on the circumstances. Date time. Date time is a big one. That can be formatted in a variety of different ways. Date time, I find in a lot of the things that I've done in the past, are very crucial as opposed to having like an insert date when a record's inserted into the database, when a record is created, when a record is altered. And also, date time can be formatted in multiple ways, which we'll get into a little bit later. You also will have large objects, you will have spatial, and you will have JSON. JSON, you'll be working with whole documents, especially if you're trying to automate and ingest data. So, those are just a few of the types that you'll see. And then we'll start digging into those specifically. Okay, so when we're talking about character types, there's two main types that you're going to be seeing, which is the char and the varchar. Now, when you're declaring those types of data, especially when you're designing your tables, you're going to want to make sure that you design it and understand the length of it, which when you're coding it into your query or design of your table, you're going to want to declare it as a char or a varchar. And in the brackets next to it, you'll want to go ahead and define the length. Now, these are fixed and they can only go up to 255 characters. So sometimes when you're designing, you want to design it with the least amount of space that you're going to take up to optimize your databases. So for example, if I were going to define a field and I was going to use a character data type, let's say to put someone's first name in that field, what I would do is I wouldn't design it to say a char up to 255 because the likelihood of someone's first name being 255 characters is probably pretty small. So to optimize your database, what you would do is you would declare it as a char, but then you would also limit your characters to save space in your database. This is also very useful because when you're running your queries run having to search through things. And so the shorter you can make these and the more efficient, the faster all of your things will run. So again, if I were going to design a first name and use the char data type, what I would do is probably declare it as a char and then maybe 25 right next to it. So I'm saying the max allowance in that field would be 25 characters and it wouldn't go up to the 255. So you will learn little tips and tricks like this along the way. This will help you in order to architect and design things thoughtfully. And it'll help save space in your database. This is one of the key things that you would be really good to learn early on, just because as you branch out further and further with your design, you will see that making these things efficient, just like that, is very, very helpful. So the next data type we're going to be reviewing are integer types. And there's quite a few integer types, and the same rule of thumb really applies not only to characters and varchars, but they also apply to integer types as well, where in the spirit of optimizing and making things more efficient and saving as much space as possible, you're going to want to declare these types to be as efficient and the best use of your storage. So, with that, you can declare integers because that is just a plain numbers field. Um, and if you're not sure on the size of what you'll be dealing with, it's always a pretty safe bet to use those. They are robust enough where they hold enough numeric values and whole numbers, and they aren't the large storage containers that you could be using, like the big ints. Um, Another type that is very useful are Booleans. If you just need something to satisfy a criteria of just two different things, either it's a true, false, or a yes, no, a Boolean is a great way to store those types of information. When you start getting into integers, also, you're going to want to look at things like tiny ints, which store just really small data types. A good example of that is, let's say you've got a lookup table and you only have maybe, I don't know, 10 different types of things you're going to look up from another table. And you have them numerically indexed, like what you all have been doing in your labs in 6 and 7, to where maybe it's just 1 through 10. A tiny int and declaring it that way is also very helpful because you're not taking all this storage up with a regular integer. It's a tiny int. So think of it in terms like that. This is also so important when you go to design uh, other fields that you're adding on to tables that are already also large tables, because if something is already a pretty big table, you want to be thoughtful about what you're adding to it in order to be able to continuously make them efficient to pull your data from. Another thing that I think that's important to touch on with the integers is you can use things like big ints. You can use things uh, that will hold larger data types, but you have to be very thoughtful about what they are and how often they're going to be used. Because at times now you're going to have to store those also. And when you're storing things in a database, that really comes into play. So when you use big ints, it's not that you can't use them, but you need to be thoughtful on how you use them. Okay, so let's talk about decimals now. There are a couple of types to consider. If you are going to use the decimal keyword, that is going to be a fixed type. So always remember that versus the float. And if you're using a float, those can be very useful too, depending on the size of the information that you have going into that field. Sometimes things may not round properly, and so you're going to need additional places. Sometimes you're going to have additional data that's ingested into your database through automation or through manual processing, and so you're going to need extra decimal points other than the 2 for rounding or other purposes. So it's always a good idea to understand the data type. It's also a good thing to know the types of information that's going to be flowing in through these, so you have a better understanding on if you're going to need to round these, if these need to be fixed, or what the situation is. So just always kind of consider those types of things before you start declaring whether it's going to be a float or it's going to be a double or just a plain decimal, because they are not coded the same. And you'll want to make sure that as you declare these, that they are properly inserted into the database. Otherwise, if the information is additional other than, let's say you've got something that holds 4 numbers past the decimal, uh, and you declare it as a decimal, then the last 2 digits are going to be truncated and you won't get that information. It will just fall off because it's only going to read the first 2. So those are things to consider when you're using those types of data types. Okay, so on to the date and time types. This type of information, I think, is very crucial and something that I think you will also find to be very useful, especially when you start doing projects like data mining. I can tell you from just experience that having a date, a timestamp, a date time field inside of a record helps tremendously when you are starting to look for things. Um, Dates can be placed in fields to have insert dates, to create dates, for updates. Uh, they play a pivotal role when you really have to go start searching for needles in haystacks, when you start looking how to find indexing, when you try to start filtering. I can tell you from just doing a lot of report development, a lot of your parameters that you will use, your start and end date. And so those types of things become crucial, and the design of them in the tables are key. So when you're looking at those types of things, just remind yourselves that yes, you can just use a date field. Um, Depending on the nature of what you're doing, if you're inserting records into a database, a timestamp field is also very helpful. So when you start working through automation processes in the event, you need to know when something was inserted or perhaps when something was updated in case an update script runs and changes are made to large data sets at one time. Those fields become very important, and learning how to search with them is very crucial. So, when you're working with the enum and the set types, those are also very useful types of fields to have in your database. If you're working with enum, the nice thing about it is it just can store one value that's selected from a list, and it is actually treated like an integer. Uh, when you're working with set, as you can tell from the chart on page 245, which is also very helpful, it's going to also explain to you that you have the ability to store multiple values in that field, but you want to be careful about overstoring in that field. Um, it gets into a place where sometimes you can use that and it is helpful, but other times it might be just more helpful to create a lookup table. So use those two fields thoughtfully and make sure that you're not overusing the set. And the enum is very helpful because then it's minimizing storage in your database. And again, now that you've got your DBA hats on, you want to start thinking about architecture and design, which is where a lot of this plays into. Okay, so when you're working with large object types, I always want to throw caution to the wind when I talk about this because it's not like I discourage anyone from using these. I just think it's important to point out that this can eat up a lot of storage in your database. And as you keep your DBA hats on and as you're learning to program, you will see, and especially out into the working world, you have to pay for storage of your databases. So, for example, a long time ago when I worked for Whole Foods, Amazon bought us and we were able to use Amazon servers. And if you've ever used an instance of Amazon or what they call an EC2 instance, uh, unless you're Whole Foods, and even then we still paid for it, but your company will be paying for on-premises storage in the form of physical servers, or they will be paying for a cloud storage like an Amazon server. So what's key is when you're thinking about architecting a lot of these things, storage is key because you pay as you go. And so the more things that you're storing, the more money it is going to be costing a business to store those things. So this is why I've been kind of preaching the gospel as to why it is important to keep things as minimum and as efficient as possible, because you want to be very careful on storage because it will cost you. If you are a small business and you are having to foot the bill yourself or a sole proprietor, you're also going to see that it hit the wallet. So large object types can be very useful in the right capacity. But what I would say is that your book discusses it on page like 247 where you've got a chart on the storage, and some of these data types can hold many megabytes. But again, I would be very careful and very thoughtful on how you use them. Sometimes you can't get around it. It may be a really long file path, it may be a link to something. It could be many things. But again, just be thoughtful and careful. I think it's important for you to understand that these things are out there, but I also think it's very crucial for you to understand how to use them and when to use them, and that you shouldn't just declare the largest data type possible. It's always really smart to look at how you can do it with the least bit possible, the smallest thing that you can use without crippling yourself in your database. So, up until this point, we have talked a lot about multiple data types and how they're declared and how they're used, whether they're integers, they're decimals. Uh, so, now date time. So, now what we're doing is we are actually looking at converting data. I remember we had a discussion board that talked a lot about implicitly and explicitly talking about data. And so this is where the implicit and explicit is going to also come into play. So let's talk about data conversion. You can implicitly convert data, and you can also explicitly convert data. Some really good examples are in your book on page 249, and they talk about number to string data, they talk about string to number data, and they also talk about date to number data. So there's a few examples that I want you to look at, and those are going to be also implicit syntactical examples of how you would convert your data. Now, when you're explicitly converting your data, you're going to use two functions. You are going to either use the cast function or you're going to use the convert function. Both of those are extremely useful. Uh, they're they're close to being used the same way. If you're casting something, you will use your keyword cast, and then you'll also have your expression, and then you will alias that as well in your parentheses. If you are converting a function, or if you're converting, you'll use the convert function. And what I mean by that is you will use the convert, and you will also have your expression, and you'll also have followed by a comma. Otherwise, it will throw an error, and you will cast the new type that you are trying to change your data to. So these can be very helpful. I've personally used these quite a bit, especially with date functions. Sometimes you will work with different businesses and companies. Maybe they store data in different manners. Perhaps they are in different time zones. They're in different countries. And so therefore they represent their dates and times in different ways that's useful to them. So that being said, make sure that you are very aware of the two different types. They can both be very useful, just kind of depending on the need and the way that they are initially stored and ingested into your database.